Hello and welcome to all. In previous session, we have discussed about the principle of reversibility of the path of light. With the help of this concept, we have to understand that the direction of light is reversal in nature. That is, it moves in backward direction and follow the same path which it travel in forward direction. Now, today we will discuss about the diffraction of light through a rectangular block. Here, the PQRS is a rectangular block, and this is represent the medium glass. This is glass, rectangular glass, and this is air, and this is also air, and light is passes from air to glass and then again glass to air. This is the simple diagram related to the reflection of light through rectangular block. Here the AO is the incident ray, and the incident ray is incident at point O of this partition line, that is PQ. Here MN is the normal to this separation line or partition line. Normal means it is perpendicular to this plane. Then here AO is refracted ray, and OB is sorry AO is incident ray and OB is refracted ray. We know that if a light ray travel from rarer to denser medium, here air is rarer medium or glass is denser medium. When light rays travel from rarer to denser medium, it bends towards the normal. Then we can see that from this diagram, the path of incident ray is this is the path of incident ray or direction of incident ray, but the refracted ray is slightly bended towards the normal. Then OB represent the refracted ray in glass medium, and here I is angle of incidence or incidence angle, and R is the refracted angle or angle of refraction. During the movement of light rays in glass, it follow a straight line. Therefore, OB is a straight line, and at point B, it again refracted and passed from glass to air. Therefore, we know that if a light ray passes from denser medium to rarer medium, the direction of light rays bend away from the normal. Here, the MN, this MN represent the normal to this surface RS. It is also a separating line or separating surface between air and glass. And point B is the point of emergence from which the light rays is emerged from glass to air, and it bend away from the normal. Here the for this case, for this refraction at point B, the R is the incident at point B, and E is the angle of emergence at point B. Here, the refraction of light is takes place at point O and point B. At point O, the light travels from air to glass, then the light rays bended towards normal, that is nearer to Mn, and when again it refracted at point B, then the light rays moves from glass to air, and the light rays bend away from the normal, that is slightly away from Mn. This is the normal at point B. Here the AO is the incident ray. This is the AO. This is the incident ray, and incident angle is angle AON. Incident angle is angle AON. This is I. Here the incident angle is I. Incident angle is I, and refracted ray, that is OB. This is the refracted ray, and refracted angle is angle MOB. Refracted angle is MOB, that is R. Then the refracted angle will be the R, and here emergent ray, that is B to C. This is the emergent ray at point B, and emergent angle is angle MBC. This is the angle MBC, angle E. This is the emergent angle. In this case, we have seen that the line PQ and RS, these two lines PQ and RS, these two lines are parallel to each other. Therefore, and the line OB is cut these two parallel lines. Therefore, this angle will be equal to this angle. These two angles are alternate angle. Therefore, this is R. Then this will also be equal to R. And here, the light rays from uh, denser to rarer medium, it bend away from the normal. Then in this condition, the refracted, the emergent angle will be equal to the incidence angle, that is the angle I will be equal to the angle E. Incident angle is equal to emergent angle, and the line BE is parallel to the direction of line of incident ray, and this is the AOM. AOM is the line of incident ray which is parallel to the emergent ray. And if you want to draw a perpendicular line between these two parallel lines, this is the separation which is known as the perpendicular distance. If we represent here xy, then xy is the perpendicular distance between these two parallel lines, and this is known as lateral displacement. Lateral displacement of a light ray. Lateral displacement represent basically the displacement of light from its original position when the light rays passes from one medium to another medium. Here, the emergent ray is parallel to the incident ray but not along the incident ray. Therefore, this represent the uh, separation of emergent ray from the direction of incident ray, which is expressed in the lateral displacement of light ray when moving from rarer to denser medium, that is reflection of light through rarer medium to denser medium. Now from reflection of light we know that reflection of light at interface PQ and point O, this is the ratio of sine of the incident angle with sine of the refracted angle. Here incident angle is I and refracted angle is R. Therefore mu12 will be expressed as sine I upon sine R, which is constant. Here mu is constant. And refraction of light at interface RS and at point B. In this condition, this R is act as the incident angle at point B, and here E is represent the reflected angle at point E. Therefore, mu21 is expressed as sin R upon sin E, and the emergent angle is equal to the incident angle. That is, the emergent angle E will be equal to the incident angle I. Then it can be written as sin R upon sin I, and if you multiply these two refractive index, this is equal to 1. We have got this result with the help of this. Thank you.